Well, hi there, kiddos. Today we are going to talk about writing equations for linear functions, which is not entirely new to you. We've been doing this all along. Every time we've had a word problem, we have written an equation from that word problem. We're just going to do it some more. Practice makes perfect, and the more practice we do, the better we get at it. So I'll try to keep this short. It's only 3 examples. Example number 1 is about Jessica going to the state fair. So she goes to the state fair of Texas. The cost of admission is $14 because she didn't pick up her free ticket at school. And then each food coupon is 50 cents. So the first thing it asks us to do is write let statements and an equation to represent Jessica's total cost at the fair. Let statements we've talked about before, but just a reminder, a let statement is just a statement of what variables you're using and what they represent. So we have 2 things. She is going to have her total cost at the fair, so we're going to let T equal our total cost. So in order for this to be a let statement, we would say let T equal the total cost. And then our second let statement would be, we would say that we want to let C equal the number of food coupons, because that's the other thing we do not know. So these are our 2 let statements. We now know, and anybody looking at this problem now knows, that T is the total cost, C is the number of food coupons. It is always, always extremely important to know what your variables are and what they stand for. If you don't know what those variables represent, the problem, when you solve it, won't mean much to you. So now let's write an equation. We know that her total cost is going to equal her cost of admission, which is $14, plus the number of food coupons she buys at 50 cents each. So that is going to be our equation that will represent our total cost at the fair. $14 plus 50 cents per food coupon. So now part B asks us to do stuff with that equation. It says if Jessica buys 40 food coupons, how much did she spend at the fair? Well, they just want us to evaluate, plug in 40, see what it equals. So T is equal to 14 plus 0.50 times 40, because she's going to buy 40 food coupons. And so I have my total cost is equal to 14 plus 20. And if I do that math, I get that her total cost was $34, because 14 plus 20 is going to make 34. So if she buys 40 coupons, it's going to cost her $34 to go to the fair. Now part C says that if Jessica spends $26.50, how many food coupons did she buy? So now they're giving us the total cost and asking for the number of coupons. So same equation, but instead of T this time I'm going to put $26.50, because that's the total cost they gave us. So then I have equals 14 plus 0.50 times C, and we're trying to find C, so we will solve this equation like we've solved equations for 2 weeks. We'll subtract 14. And so I have that $12.50 is equal to 50 cents per coupon. And if I want to find out how many coupons, I'll divide by 50 cents. And when I divide that by 50 cents, I get that she bought 25 coupons. Part D is the same kind of question. They're just asking it in a different way. It says Jessica's got $31 to spend. How many food coupons can she buy? So now we know how much she has to spend. What's her maximum food coupons? So she has $31. And this was our equation. And we get to solve this just like we solved the one before. So we subtract 14 from both sides. And so we have 17 is equal to 0.50 C, and then when I divide both sides by 0.50, or 50 cents, I get that she could buy 34 coupons if she only has $31 to spend. That is if Jessica only goes to the fair and eats food. She didn't go to the Midway and play any games. She didn't go buy anything in any of the little shops. She went to the fair and she ate food, which we all know the Midway is the most fun, but we also know that the food is quite awesome and bad for you, and so we want to eat a lot of it. So it's not unreasonable that she would just go and eat a lot, because they fry everything at the State Fair of Texas. So let's do a couple of other questions. This next one, number 2, it can be it's not hard. It's just interesting to set up. So that's why this one is in here. So we know that Jenna's pre-AP algebra grade after the first 6 weeks was 70%. She wanted her grade to improve, so she began to study at least an extra hour a day. As Jenna tracked the number of extra hours she studied, she realized her average went up by 2% for every extra 5 hours of extra study time. So we got to write an equation that represents her total average as a function of hours. Means that we're going to have her total average and the number of hours. Those are going to end up being our two variables. So let's write our let statements. We're going to let A equal her total average, and we're going to let H equal the number of hours of study time, or of extra study time. So this 2% for every 5 hours. How we're going to write that is going to be really interesting. Up to this point, I've told you, you got a percent, make it a decimal. If you have a percent, make it a decimal. That's super. You should usually do that. But if you think about how we measure our grades, all your grades, when you get them, are measured in percentages. You made 100% on the test, or you made a 45% on the homework, or you made an 83% on the quiz. But one way or the other, you made a percent. It was a percent grade. And so this 2% is not really a percent like it would be in a commission problem or one of those problems where we're getting something for a discount. This is percentage points on her grade. So what this really means is that her grade goes up 2 points for every extra 5 hours of study time. So when I set up this problem, I'm going to leave it as a 2 instead of making it a decimal, because it really represents points on her grade. And I'm going to write it as a ratio. Her grade goes up 2 points for every 5 hours that she studies. That's going to represent this statement right here, and is going to help us when we set up our equation, that we know this. It increases 2% for every 5 hours of study time. This is a ratio that compares those two things. So now we're going to write our equation. Her average. We know right now that she has a 70. But she wants it to go up, and so she found out that it went up 2% for every 5 hours of study time. And so there is my equation that I can use to figure out what her average will be if she studies this many extra hours or that many extra hours. So that's what the equation looks like, and that 2/5 came from the fact that it goes up 2% for every 5 hours. So part B asks for her average after 30 hours. So we're just going to find out. Well, A equals 70 plus 2% for every 5 hours times 30 hours. Well, we know how to multiply fractions straight across this. We could do 30 over 1. You also have a calculator at this point. You can type in 2/5. You can do 2 divided by 5. It doesn't matter. We're going to solve this problem. So 2/5 of 30 is going to be 12. So I end up with 70 plus 12. And so her new average is going to be an 82. If she studies 30 extra hours, she will now make an 82 instead of a 70. So part C says if her average is now 86, how many extra hours did she study? So now we're going backwards. She has an 86. We want to know how many extra hours she studied. So we'll just solve this like we've solved equations, like I said before, like we've been doing for 2 weeks. So we'll subtract 70 from both sides. And so when I do that, I get 16 equals 2/5 H. And now I've got a fraction here. I'm going to clear out that fraction by multiplying by the denominator. So I'll multiply both sides by 5. And so I have that 80 equals 2H. And if I want to know how many hours she studied, I'll divide by 2, and I get that she studied 40 extra hours. That is what H equals. And so that's how we solve that problem, and that's how it gets set up. So this last one's pretty easy. Okay, first of all, we have a candy company. Everybody likes candy. So a candy company sells boxes of chocolate-covered almonds. Oh, sounds delicious. The empty box weighs 5.7 ounces, and each piece of candy weighs 1.6 ounces. We want to write an equation to represent the total weight in ounces, W, of a box of chocolate-covered almonds in terms of A, the number of candies in the box. In this instance, they gave us the variables they want us to use. So we don't really have to write let statements. They told us in the words, W is the total weight, A is the number of candies. So we know what variables to use and what they represent. We don't have to write let statements, but we do have to write an equation. And if you would notice, when you read that last sentence, nowhere in there does it say write an equation and solve it. It just says write an equation. So we're going to write an equation to be done. So the total weight of our box is going to be the empty box at 5.7 ounces plus 1.6 ounces per candy. And so that's going to be my equation, or almonds, whatever. But that's how I find the total weight of the box. I take the empty box plus the number of ounces there are per almond, and then I add them together. It gives me the total weight of the entire box, almonds and everything all inside. So there is the equation for that. That is all there is to writing equations for linear functions. We will practice this when you come to class tomorrow. I will see you then. Have a good rest of your evening.